ancient harvests and modern science. There is a table that has been set for thousands of years, not in any single home, not in any one country, but across the pages of the oldest living text in the Western world, woven through stories of wandering and exile, of celebration and mourning, of creation and covenant. And on that table, in those stories, is food, real food, grains and legumes, and fruits and oils. The kind of food that built civilizations. The kind of food that people are still eating today, still growing, still studying, and, it turns out, still discovering. For centuries, these foods were understood primarily through the lens of sustenance and symbol. Bread was life, wine was blessing, oil was consecration. The foods of the biblical world carried meaning that went far beyond nutrition. Then, modern science arrived with a different set of questions. Not what does this food represent, but what does it contain? Not what did the ancients believe about it, but what does the laboratory reveal? And what the laboratory has been revealing, slowly and persistently across the last several decades, is that many of the foods most central to the biblical world are among the most nutritionally and biochemically interesting foods that science has so far examined. This is not a coincidence without explanation. The people of the ancient Levant ate what the land gave them. They observed, over generations, what sustained them and what did not, what gave them strength and what made them ill. They encoded that observation into culture, into ritual, into the very text that has survived to this day. And now, for the first time in history, we have the tools to begin reading that encoding in a different language, the language of biochemistry, the language of clinical trials and longitudinal cohort studies and meta-analyses. What we find when we look at the food of the Bible through that lens is not a set of mystical secrets. It is something quieter and more honest. It is the recognition that human beings, paying close attention to the earth for long enough, arrived at something genuinely useful. And that the most ancient agricultural wisdom and the most advanced nutritional science are, in many cases, describing the same thing. Stay with this journey. Because somewhere between a field of ancient grain and a modern research laboratory, there is a conversation worth hearing. Let us begin underground, with the roots and bulbs that formed the foundation of ancient diet across the Levant and Egypt. Garlic is one of the oldest cultivated plants in human history. Its presence in the ancient world is not in question. In the book of Numbers, when the Israelites are wandering in the wilderness and beginning to tire of manna, they remember what they have left behind in Egypt with a specific and heartfelt longing. They recall fish and cucumbers and melons and leeks and onions, and they name garlic by name. That single verse tells us something significant. Garlic was not simply present in Egypt. It was remembered. It was missed. It had earned a place in the emotional geography of a people in exile. Modern science has spent considerable energy on garlic, and what it has found justifies that emotional attachment in ways the ancient Israelites could not have articulated. The characteristic compound in garlic is allicin, produced when raw garlic is cut or crushed, and the compound alliin interacts with the enzyme alliinase. Allicin belongs to a broader family of organosulfur compounds that have been studied extensively for their biological activity. Human clinical trials have examined garlic preparations in relation to cardiovascular markers, particularly blood pressure and cholesterol levels, with a number of meta-analyses of randomized controlled trials, suggesting modest but measurable effects. Laboratory research has also explored garlic's antimicrobial properties, which were well known in ancient practice. Some of the most interesting recent research has examined aged garlic extract specifically, which contains different compounds than fresh garlic, and has been studied in relation to immune function and vascular health. Evidence continues to accumulate, and researchers are careful about overstatement. But the volume and consistency of the research signal is notable. A bulb, remembered with longing by a wandering people in a desert, has turned out to contain some of the most studied phytochemicals in nutritional science. Beside garlic in that verse from Numbers stands the onion, and with it, the leaf. Onions are among the most ancient cultivated foods on Earth. Archaeologists have found evidence of onion cultivation in Egypt dating back more than 5,000 years. They appear in records of workers' rations at ancient building sites. They were buried with pharaohs. They were, in every sense, a staple of life in the ancient world. The humble onion belongs to the same allium genus as garlic, and it shares some of its biochemical relatives, including compounds called thiosulfonates. But the onion has its own distinct profile of interest. Modern research has focused particularly on quercetin, a flavonoid present in high concentrations in onion skins and outer layers. Quercetin has been studied extensively as an antioxidant, and there is ongoing interest in its potential effects on inflammatory pathways. Some human studies have examined onion consumption in relation to bone density, cardiovascular markers, and immune response. The evidence is still being refined, and the complexity of whole food research makes drawing clean conclusions difficult. But quercetin remains one of the most actively studied plant polyphenols in current nutritional science. The leek, also named in that passage from Numbers, belongs to the same family. It is milder than garlic, more subtle than onion, but it carries its own profile of organosulfur compounds and flavonoids. Traditional medicine across the Mediterranean world used leeks for conditions ranging from digestive complaints to throat health. Modern research has examined leek extracts in laboratory models, finding activity that aligns, broadly, with some of those traditional applications. 3 plants, remembered with longing in the same breath, from the same family, all now subject to active scientific investigation for compounds that turn out to be genuinely interesting. From the gardens of Egypt and the fields of Canaan, we move now into the landscape that defines the biblical world more than perhaps any other: the grain fields. Wheat and barley are the backbone of the biblical economy, the foundation of daily bread, the material of offering and tithe and trade. In the book of Ruth, the entire arc of redemption turns on a barley harvest. In the book of Ezekiel, the prophet is given a precise recipe for bread made from wheat and barley and lentils and millet and spelt. In the feeding of 5,000 people, it is barley loaves that are multiplied. These are not incidental details. Grain was life. Grain was civilization. But when we think about wheat and barley today, we are often thinking about them in their highly refined modern forms. White flour, processed products, the grains stripped of their outer layers, in the service of shelf life and texture. The wheat and barley of the ancient world were different. They were whole, unrefined, dense with what scientists now call bioactive components, and what ancient people simply called food. Modern nutritional science has developed a substantial body of research around whole grains. Wheatgrass and barley grass, the young green shoots harvested before the grain head forms, have been studied separately as concentrated sources of nutrients, including chlorophyll, antioxidants, vitamins, and enzymes. Some human studies have examined barley grass juice for its effects on certain metabolic markers, including cholesterol and blood glucose, with modest but positive results in some trials. The evidence base for these young grasses is still relatively limited compared to the whole grains themselves, but research interest continues. Whole grain barley contains a form of soluble fiber called beta-glucan that has been extensively studied and that now has regulatory recognition in several countries for its effects on cholesterol levels. Beta-glucan has been examined in numerous randomized controlled trials, with consistent findings suggesting a meaningful relationship between beta-glucan intake and LDL cholesterol reduction. This is one of the more robustly supported claims in all of dietary fiber research. Whole wheat, similarly, is the subject of large cohort studies and meta-analyses examining associations between whole grain intake and a range of health outcomes. The consistent direction of this evidence has driven public health recommendations across the world. The bread of the ancient world was, by modern standards, extraordinarily nutritious. Not by design, in the sense of deliberate nutritional planning, but because the technology to remove what we now know to be the most valuable parts had not yet been invented. Alongside the grain in the biblical field stood flax. Flax, Linum usitatissimum, is one of the oldest cultivated plants in the world. In the book of Exodus, when the plagues strike Egypt, a hailstorm destroys the flax because the flax was in bloom. This is an agricultural detail, precise and specific. The flax harvest was significant enough that its destruction was worth recording as a particular loss. Flax was used for linen, for oil, for food. Rahab in the book of Joshua hides 2 spies under stalks of flax drying on her roof. The plant appears at key moments, always as background, always as evidence of the texture of daily life. Modern nutritional science has developed enormous interest in flaxseed over the last several decades. Flaxseed is one of the richest plant sources of alpha-linolenic acid, an omega-3 fatty acid, and it also contains a class of compounds called lignans, which are phytoestrogens studied for various potential health effects. Multiple human clinical trials have examined flaxseed supplementation in relation to cardiovascular markers, menopausal symptoms, blood glucose regulation, and inflammatory markers. The results are mixed across different outcomes, and researchers continue to work on questions of dosage, processing, and individual variation. But the scientific interest in flaxseed is genuine and substantial. A plant whose stalks were used to hide spies and whose fibers clothed a civilization turns out to contain seeds that nutritional scientists count among the most biochemically active whole foods currently under investigation. Now from the fields into the orchards. The olive tree stands at the center of the biblical landscape like no other plant. Olive oil is anointing oil. It is the oil of the menorah. It is the oil that the widow's jar never runs out of in the story told in 1 Kings. When Noah's dove returns to the ark, it carries an olive branch. The Mount of Olives gives its name to one of the most sacred sites in the entire biblical narrative. The olive is not incidentally present in these texts. It is woven into their deepest meaning. And olive oil has become, in the last 3 decades, one of the most studied dietary fats in all of nutritional science. The primary fatty acid in olive oil is oleic acid, a monounsaturated fatty acid. But the research interest in olive oil goes beyond its fatty acid profile. Extra virgin olive oil contains a range of polyphenolic compounds, including oleocanthal, which has attracted particular attention from researchers. Studies in laboratory models have found that oleocanthal has properties that are structurally and functionally similar to certain anti-inflammatory agents. Human clinical trials examining olive oil as part of the Mediterranean dietary pattern have produced some of the most compelling dietary intervention data in modern nutritional epidemiology. Large trials have examined outcomes related to cardiovascular health, cognitive function, and metabolic health in populations consuming diets rich in extra virgin olive oil. The direction of evidence has been consistently positive, though researchers continue to work on questions of mechanism and causality. The oil that anointed kings and fed prophets and burned in sacred lamps is now the subject of some of the most rigorously conducted dietary research in the world. The ancient instinct to regard it as something precious turns out to have a biochemical basis that the ancient world could not have imagined, but would not, perhaps, have been surprised by. In the same orchard where the olive grows, in the same ancient landscape, stands the pomegranate. Pomegranates appear throughout the Hebrew scriptures with a striking frequency. The hem of the high priest's robe was decorated with embroidered pomegranates. The capitals of the pillars of Solomon's temple were carved with them. In the Song of Songs, the beloved's temples are compared to slices of pomegranate. In Deuteronomy, the pomegranate is listed among the 7 species that define the goodness of the Promised Land. This level of presence in sacred and ceremonial contexts is not decorative. Pomegranates were considered symbols of abundance and righteousness in the ancient world, in part because of their seeds, of which tradition counted many hundreds, and in part because of their deep red color, which carried its own weight of meaning. Modern research on pomegranate has become substantial in recent years. The fruit contains a range of polyphenols, particularly L-agitannins, which during digestion can be converted by gut bacteria into compounds called urolithins. Urolithins have attracted considerable scientific attention, with laboratory studies examining their potential biological activity and some human trials beginning to explore their effects on various markers. Pomegranate juice has been the subject of clinical trials examining cardiovascular markers, with some studies reporting effects on blood pressure and oxidative stress. The research is ongoing, and some findings require replication in larger studies, but the pomegranate has earned a genuine place in contemporary nutritional science. A fruit carved into the pillars of a temple and embroidered into the garments of priests turns out to contain compounds that researchers are now studying with serious intent. Not far from the pomegranate, in the landscape of the ancient Near East, grows the date palm. The date palm, Phoenix dactylifera, is among the oldest cultivated trees in human history. It appears throughout the Hebrew scriptures, sometimes as symbol, sometimes as landmark, sometimes simply as food. Jericho was called the City of Palms. The Book of Psalms uses the image of the righteous person flourishing like a palm tree. Deborah the prophetess held court under a palm tree. And dates themselves, the fruit of this tree, were among the most important caloric foods in the ancient Levant, sweet and dense, and storable in a landscape where fresh food was often seasonal and uncertain. Modern research on dates has examined a fruit that is, by any measure, nutritionally dense. Dates contain natural sugars, fiber, potassium, magnesium, and a range of polyphenolic compounds. Some research has looked at the potential effects of date consumption on digestive health, noting their fiber content and their traditional use as a remedy for constipation. Studies have also examined dates for antioxidant properties, and some clinical research has explored their potential effects on labor outcomes in late pregnancy, with findings suggesting that date consumption in the final weeks of pregnancy may be associated with more favorable delivery outcomes. This latter research is still at relatively early stages and requires confirmation from larger studies. A tree that gave its name to a city and its image to righteousness has also given humanity one of its most reliable sources of natural energy, in a form that modern analysis continues to examine with interest. Here, at the midpoint of our journey through the food of the biblical world, something worth pausing to acknowledge. We have moved through the fields and orchards and gardens of an ancient agricultural civilization. We have found that the foods at the center of that civilization, the foods named with care, remembered with longing, carved into temples and woven into priestly garments and embedded in the deepest stories a culture tells about itself, are among the most nutritionally complex and biologically active foods that modern science has so far examined. This is not magic, it is selection. Over thousands of years of cultivation and observation and use, the agricultural cultures of the ancient Near East settled on the foods that best sustained them. Not through randomized controlled trials or nutritional analysis, but through experience, through watching what happened to people who ate certain things regularly, over many years, across many generations, through noticing what gave energy and what depleted it, what supported longevity and what shortened life. The result of that long, slow, observational process was a dietary pattern that modern nutritional science has spent decades studying, and that it has, in its more careful moments, found to be genuinely remarkable. The ancient people who cultivated these foods did not know what polyphenols were. They did not know about omega-3 fatty acids or beta-glucan or elagitannins, but they knew what worked. And what they knew has turned out, under the light of modern investigation, to have been pointing in a direction that was, more often than not, right. Let us continue, because the table is not yet complete. The almond tree holds a special place among biblical trees, not just as food, but as symbol. In the book of Numbers, Aaron's staff miraculously blooms and produces almonds overnight, a sign of divine selection. The lampstand in the tabernacle, the menorah, was designed with cups shaped like almond blossoms. The Hebrew word for almond, shach, is also the word used for watchful or wakeful. The almond tree was named for the fact that it is the first tree to bloom in winter, waking before all others, watchful before the season has changed. The almond is the first to bloom, and modern science has found it to be among the most nutritionally complex of tree nuts. Almonds contain monounsaturated fats, vitamin E, magnesium, and fiber, as well as a range of polyphenolic compounds concentrated particularly in the skin. Large cohort studies have found consistent associations between tree nut consumption, including almonds, and various health markers. Clinical trials examining almond supplementation have explored effects on cardiovascular risk factors, blood glucose management, and satiety. The evidence base for almonds is among the stronger bodies of research for any single whole food. A tree named for wakefulness, whose blossoms were carved into the sacred lampstand of the tabernacle, turns out to carry in its fruit a biochemical profile that nutritional scientists regard as genuinely worthy of attention. From the cultivated orchards into the more humble corners of the biblical landscape, we find two trees often overlooked in favor of their more celebrated neighbors. The sycamore fig, Ficus sycamoris, is not the fig most people imagine when they think of biblical fruit. It is a different species, stockier, its fruit smaller and less refined than the common fig, sweeter in some accounts, and more accessible because the tree grows low and wide rather than tall. In the book of Amos, the prophet describes himself as a herdsman and a dresser of sycamore figs, a specific agricultural practice that involved cutting the fruit to promote ripening. In the Gospel of Luke, a man named Zacchaeus climbs a sycamore fig tree to see Jesus over the heads of the crowd, a detail that tells us something about the tree's accessible, wide-branching nature. This was a tree of the common people. Its fruit fed those who could not afford better, and the people who ate it were, without knowing it, consuming a fruit that modern analysis has found to contain a range of bioactive compounds, including polyphenols and various phytochemicals, whose properties researchers continue to investigate. The mulberry, too, appears in the biblical narrative. In the second book of Samuel, David receives instruction to listen for the sound of marching in the mulberry trees as a signal to attack, a detail that places mulberry trees in a specific landscape and moment. In the Psalms, there is reference to vines being destroyed by hail and mulberry trees by frost, again as background detail. The mulberry does not occupy a symbolic role in the biblical text, but it was present, it was known, and its fruit was eaten. Modern research on mulberry, particularly the black mulberry, Morus nigra, and white mulberry, Morus alba, has identified several compounds of interest. The fruit contains anthocyanins, the same class of pigments responsible for the dark color of many berries, and studied broadly for antioxidant activity. White mulberry leaf has attracted particular research attention for compounds, including deoxynogeromycin, which has been examined in human studies for potential effects on postprandial blood glucose levels. The research on mulberry leaf is preliminary in many respects, but the direction of interest is genuine. Among the legumes of the biblical world, the record is both specific and substantial. The lentil may be the most emotionally charged food in all of Scripture. In Genesis, Esau returns from the field exhausted and famished. He smells lentil stew, and in a moment that has echoed through 3,000 years of commentary, he sells his birthright for a bowl of it. The text does not judge this as excess. It presents it as human, the scent of something warm and filling and immediate, weighing against something abstract and future. Lentils were the food of the everyday person in the ancient Near East. They were storable, affordable, filling, and they grew in the thin soils of the Levant where other crops struggled. Modern nutritional research has been uniformly positive about lentils. They are among the most nutrient-dense legumes available, with high protein content, complex carbohydrates, iron, folate, and fiber. They have a low glycemic index, meaning they produce a slow and gradual rise in blood glucose, rather than a sharp spike. Multiple clinical and epidemiological studies have examined legume consumption in relation to cardiovascular health, blood glucose management, and satiety. The evidence consistently supports legumes as among the most beneficial categories of whole food for metabolic health. Lentils specifically have been studied for their content of polyphenols, including tannins and flavonoids, as well as resistant starch, a form of carbohydrate that reaches the large intestine intact and serves as fuel for beneficial gut microorganisms. A bowl of stew that was worth a birthright turns out to have been worth considerably more than that, in ways that a modern nutritionist would be happy to explain. The bean, the chickpea, and millet complete the biblical pantry of legumes and small grains. Beans appear in the second book of Samuel among the provisions brought to David at Mahanaim during his flight from Absalom. They appear again in Ezekiel's bread recipe. These were staples, practical foods, the kind that sustained armies and refugees and workers. The broad bean, Vicia faba, is the most likely candidate for the biblical bean, and it remains one of the most widely consumed legumes in the world today. Modern research has examined broad beans as a source of plant protein, complex carbohydrates, fiber, and various micronutrients. There is also ongoing interest in their content of L-dopa, a compound with known neurological activity, though this aspect of the research comes with appropriate scientific caution. Chickpeas, too, appear in the biblical record and have become one of the most studied legumes in modern nutritional science. Large dietary surveys and clinical trials have examined chickpea consumption in relation to lipid profiles, blood glucose, body weight management, and gut health. The fiber and protein content of chickpeas, combined with their low glycemic index, places them consistently near the top of plant-based protein sources in dietary guidance documents around the world. Millet is among the oldest cultivated grains in human history, and it appears in Ezekiel's bread alongside wheat and barley and lentils. Modern nutritional interest in millet has grown considerably as researchers study alternative grains and their potential roles in diverse dietary patterns. Millet is gluten-free, contains a range of micronutrients, and has been examined in studies looking at blood glucose response and antioxidant content. Rye, which some scholars include among the grains referenced in the biblical record under names that resist precise translation, has become an area of active research in part because of its extraordinarily high fiber content and because the type of fiber it contains, including beta-glucan and arabinoxylans, has been associated with favorable metabolic effects in human studies. And then there are the foods that did not grow in fields, but were gathered or traded from far away, carrying their own ancient weight of meaning. The carob, Ceratonia siliqua, grows wild and cultivated across the Mediterranean basin, Its pods were used as animal fodder and as human food in lean times. In the Gospel of Luke, the prodigal son, at his lowest point, is described as longing to eat the pods that the pigs were eating, and some scholars identify these as carob pods. Carob was survival food. It was what remained when everything else was gone. Modern nutritional research has found something more in carob than survival sustenance. The carob pod contains a high proportion of soluble fiber, including specific compounds called carob fiber polyphenols and tannins that have been examined in clinical trials for effects on cholesterol and blood glucose. Some trials have found meaningful effects on LDL cholesterol with regular carob fiber supplementation. Carob also serves today as a caffeine-free alternative to chocolate, used widely in health-oriented food products. The food that marked the lowest point in a parable about returning home contains compounds that researchers are studying for their potential role in metabolic health. And finally, the oldest sweetness in the biblical world. Honey and its sources appear throughout Scripture as the ultimate symbol of abundance and blessing. The Promised Land itself is described as a land flowing with milk and honey more than 20 times across the Hebrew Scriptures. Jonathan, in the first book of Samuel, dips his staff in wild honey, and his eyes are immediately brightened, a small moment that is always read as the most natural description of sudden energy. The book of Proverbs says that pleasant words are like a honeycomb, sweet to the soul and healing to the bones. The grapes of the Promised Land, carried back by the scouts of Israel on a pole between two men, were an emblem of abundance so profound that they became legendary. And raisins, the concentrated form of that sweetness, appear in provision lists and gift offerings, and among the foods given to the exhausted and the depleted to restore their strength. Modern science has developed considerable interest in the polyphenolic content of grapes and grape products, including raisins. Grapes contain resveratrol, one of the most studied plant compounds of the last several decades, though research continues to refine understanding of its bioavailability and effects in humans. Raisins contain concentrated levels of various polyphenols, natural sugars and a matrix of fiber, and have been examined in some clinical studies for effects on blood glucose response compared to other sweet snacks, with results suggesting that the fiber matrix of the whole dried fruit moderates the glucose response in ways that isolated sugar does not. The nectar gathered by wild bees from flowers across the ancient Near East, the honey that named a promised land, has also been the subject of modern research. Studies have examined honey's antimicrobial properties, particularly certain varieties known to have a high concentration of hydrogen peroxide and other compounds. Medical-grade Manuka honey has been evaluated in clinical settings for wound care, and ongoing research continues to examine the flavonoid content of various honeys, which varies considerably based on the floral sources available to the bees that produce them. The sweetness that named a promised land was never simply sweetness. It was the concentrated labor of an ecosystem, distilled into a form that carried energy and carried meaning, and carried the scent of every flower that had contributed to it. We have now passed through the entire biblical pantry. Garlic and onion and leek, remembered with longing in a desert. Wheat and barley and flax, the foundation of civilization. Olive oil pressed from fruit that named the most sacred places in the ancient world. Pomegranate carved into temple pillars. Dates from the city named for palm trees. Almonds that were watchful before winter ended. Sycamore figs that fed the common people. Lentils, worth a birthright. Beans and chickpeas, and millet that kept armies moving. Carob that sustained the desperate. Grapes and raisins and honey that named an entire vision of the good life. What emerges from this journey is not a miracle. It is not a secret. It is the recognition that the people who built the agricultural foundations of the biblical world, who selected and cultivated and passed down the seeds and the orchards and the knowledge over thousands of years, were doing something that we are only now, with modern instruments and clinical methodology, beginning to fully appreciate. They were building a dietary pattern that, examined from the vantage point of current nutritional science, is characterized by extraordinary diversity, exceptional fiber density, robust polyphenolic content, high legume intake, consistent consumption of whole grains and healthy fats, and regular access to fermented foods and tree fruits and nutrient-dense nuts. This is, in broad terms, what the most respected nutritional research of our era describes as a health-supporting dietary pattern. Not because the ancient world knew about bioactive compounds, but because they paid close attention to what the land gave them. They ate the whole food. They preserved the seeds. They passed the knowledge forward. We inherited that pantry. And modern science has spent the last several decades opening its contents, one compound at a time, and finding that the ancient curators of that pantry knew, in their own language, quite a lot. There is something genuinely moving in that recognition. Not the discovery of something new, but the confirmation of something very old. That human beings, when they pay close attention to the living world for long enough, arrive at something true. Not completely true, not finally true, but pointing in a direction that is worth following. The fields of the ancient world have been harvested countless times since those first cultivators saved the first seeds, and they are still being harvested. In laboratories and clinical trials and epidemiological studies that track what people eat and how they age and what sustains them. The harvest is not over. The investigation is not complete. And the table that was set in ancient times, in those fields and orchards and gardens, is still set, still full, still worth sitting down at, still worth asking what it contains.